Okay, so this is one of the last things now that we have to do in this chapter. And this thing here is called touching circles. Okay, so it's where we have two circles and they are clearly touching each other. One can be smaller than the other, it doesn't really matter. And this situation here is called external because the circles are touching each other externally. Okay, now there's one little rule that we need to know about this here. All right, and it's not in the log table, so you just need to know it. And the rule is this: if the circles touch externally, then, okay, so let's have a look at this. So here we have the radius of the small circle and the radius of the big circle, all right? And the distance here is the distance between the two centers. That is the distance there. So the rule now that we have to know is that the distance, if they touch externally, then the distance between the two centers must be equal to R1 plus R2. Okay, so let's just go over that because it's very, very important. If they touch perfectly externally like that, then the distance between the two centers should be the same as the first radius plus the second radius. Okay, so that's only if the circles touch externally. The circles can also be like this. So we have a big circle again and a small circle, but this time the small circle is inside the big circle, so they actually touch internally. Okay, so here we have the center of the big circle and the radius of the big circle is all of this, but then the radius of the small circle is just this bit here. So now we have our distance, and once again the distance is between the two centers, but this time if they touch internally, then the distance between the two centers would be equal to R1, which is the full radius, minus R2. Okay, and those are our two rules. Okay, so let's do this example here. So in this question, we want to prove that circles C1 and C2 touch externally. Okay, so if they touch externally, a diagram that it might look like is maybe there's C1 and here's C2. Okay, and we want to prove that they touch externally like that. Okay, and then they give us the equation of C1 and the equation of C2. So to prove that they touch externally, what is our rule for circles that touch externally? And remember that you need to know these rules and they're not in the log tables. So for touching externally, the rule would be that the distance between the two centers needs to be equal to the first radius plus the second radius, okay? And that is the rule that we just talked about. Okay, so let's do this question now. So as you can see, I've split the board up into two. Okay, we'll deal with circle 1 and then we'll deal with circle 2. Okay, so for circle 1, anyway, the first piece of information that I can get is the center of circle 1. And I'm hoping now that by looking at this here, you can see, remember you divide by 2 and you change the sign. So the center of circle 1 is 7, 3. Okay, and then to get the radius of circle 1, all right, because it's in this format, we have to go now and use this formula here, g squared plus f squared minus c. So if we fill that out there, we're going to get 7 squared plus 3 squared minus 49, and I have this done out already. The final answer there you get is 3. So C1 has a center of 7, 3, and it has a radius of 3. Let's do the same for C2. So for C2, we can see that the center needs to be 3 and 6. That would be the center. And the radius, once again, I would fill in this formula here, g squared plus f squared minus c, and the final answer there will be 2. Okay, so now we know about our circles, okay? We know that circle 1 has that center and that radius, and circle 2 has this center and a radius of 2. Okay, but let's go back up to our rule. The rule says that the distance between the centers has to be the same as R1 plus R2. So how do we get the distance between the centers? Okay, so to do that, we would once again have to use the junior cert formula, x2 minus x1 to be squared plus y2 minus y1 to be squared, and in it you would put these 2 points here. Okay, so that would be x1, y1, and that would be x2, y2, and you will put those numbers into the distance formula. Just to save time, I already have done that, and the distance between the two centers is equal to 5. Okay, so now we're ready to fill in this formula here. So again, the formula is the distance is equal to r1 plus r2. The distance between the two centers is 5, and that's equal to the radius of the first circle is 3 plus the radius of the second circle is 2, and yes, that does make sense. 5 is equal to 5. So there we go. That just proves that those two circles here do in fact touch externally. Okay, so I'm just going to show you now, it's the same question, but I just have a proper diagram drawn. Okay, so this circle here is C1, and it has a center of 7, 3 and a radius of 3. And this is the circle C2, it has a center of 3, 6 and a radius of 2. So using the distance formula then, we found the distance between the two centers, and we found that was 5. And then using what we know, the distance, if they touch externally, the distance needs to be equal to r1 plus r2. So we knew the distance was 5 is equal to 2 plus 3. So 5 is equal to 5. Okay, so I'm just showing you, it's the same question, I'm just showing you what it would look like as a diagram. Okay, so this is the last thing now that we're going to do in this video. So this question here is what I would see as a typical exam question, that something that will probably come up in the Leaving Cert. So let's have a look at this here. So we have two circles. The first one is S, and there's the equation of S. And then we have another circle called T, and there's the equation of T. Okay, if you notice, we don't know the full equation of T because there's a K here. Okay, there's supposed to be a number here, but we don't know what it is. Now, they tell you a piece of information, and the piece of information they tell you is that S and T definitely touch externally. Okay, so they definitely touch externally, and then obviously now they're asking us to find what K is there. All right, so that is a typical exam question. So what I'm going to ask you to do, please, is to pause the video, okay, and give yourself a good 10-15 minutes to try this question, because if this question did come up in the Leaving Cert, it would be worth probably 15 or 20 marks. So I want you to give yourself a good amount of time and give it a go. Okay, so let's have a look at this question then. So as I said, we have two circles. We know that they touch externally, and then obviously there is a number here that we need to find, K. Okay, so just a small bit of work I want to do first. So first of all, let's have a look at circle S, and then we'll have a look at circle T. So circle S is in this format here, so I'm hoping now at this stage everyone would know that its center needs to be on 0, 0, because it's in the equation is in that format, x squared plus y squared. And I would also like if everyone knew that the radius has to be 5. Okay, so that's everything we know about circle S. Over here on circle T then, okay, we can figure out what the center is. The center is going to be 5 minus 12. That's what the center is going to be. Okay, and the radius, okay, because it's in this format here, to find the radius we need to use this formula here, g squared plus f squared minus c. So let's fill this in. Okay, so it would be g squared, which is 5 squared, plus f squared, which is minus 12 squared, plus or minus whatever our c is, but our c is actually, unfortunately, a k. So to get our final answer here is that is going to be 25 plus 144 minus k, and just we can tidy that up a little bit. 25 plus 44 is going to give me an answer of 169 minus k. And unfortunately that is all we can do there for the radius because we have no idea what k is. Okay, so what I just did in this first part here is I just got this circle, I know the center and I know the radius, and I got this circle here, I know the center and I kind of know the radius. it's in terms of k. Okay, so I just cleaned the board and I just drew a diagram now of what we have. So this is circle S and this here is circle T. Circle S has a center of 0, 0 and it has a radius of 5. And circle T had a center of 5 minus 12 and it has a radius of 169 minus k. That's all we know about the radius for circle T. Okay, so where do we go from here now? Again, the question is looking for us to find k. All right, that's what the circle wants us to do. Okay, so to do that, and we also know that they touch externally. So we do know that if two circles touch externally, then the distance between the two centers is equal to the first radius plus the second radius. Okay, so the first thing I would do here is I would find the distance between the two centers. So once again, you would have to use the distance formula between 0, 0 and 5 minus 12. You would label it x1, y1, x2, y2. You would use the distance formula, okay, to find the distance between 0, 0 and 5, 12. I already have that done, and the answer is 13. Okay, so the distance between the two centers there, the distance between the two centers is 13. Okay, so I know that the distance there is 13, and that should be equal to the first radius, which is 5, plus the second radius, which is the square root of 169 minus k. And again, I know this is true because the circle, or the question, sorry, told me that the circles touch externally. So now I have this equation and I need to find k. But now this question has got absolutely nothing got to do with coordinate geometry of the circle anymore. Okay, I'm hoping that you can see it's 5th year work, all right, and it's just this third equation. So all I'm going to do here is bring over this 5, okay, and we'll get 8 is equal to the square root of 169 minus k. And then I'm hoping everyone remembers that to get rid of a third, you have to square both sides. So we get 169 minus k is equal to 64. Remember, if you square a square root, it disappears. And now finally, we are one step away from our answer there. Okay, k then will equal 105. And that is the correct answer, and that is our final answer.